Let's look at question 10.1. The event S and T are independent. Probability of S and T is 1 over 6. Probability of S is 1 over 1.1. Calculate probability of T. So what do we know about independent events? Probability of A of S and T will be equals to probability of S times probability of T. So what is S and T? It's 1 over 6 is equals to 1 over 4 times probability of T. In this case, probability of T, it is equals to 1 over 6 divided by 1 over 4, which that will give us 2 over 3. Now, hence, calculate probability of S or T. Once you see this, think about the identity. That's the probability of S or T will be equal to probability of S plus probability of T minus probability of S and T. So now, what probability of S? Part of S is 1 over 4. 1 over 4 plus probability of T is 2 over 3 minus 1 over 6, which that will give us 1 over 4 plus 2 over 3 minus 1 over 6, which that will give us what? 3 over 4. Now 10.2, a 5-digit code is created from the digits 2, 3, 5, 7, 9. We see that we're given 5 digits. To create 5-digit code, how many different codes can be created? If repetition of digits is not allowed, remember now, you choose a digit once. So choosing a digit once, it can mean that we're going to choose out of 5 factorial. Or we choose 5, we choose 4, we choose 3, we choose 2, we choose out of 1. Meaning that we choose out of all of them. We choose out of 4 because we choose 1 already. We choose out of 3 because we choose 2. Choose out of 2 because we choose 3. Choose out of 1 because we choose 4. So which is 5 factorial. Then how many are going to create? We're going to create 120 codes. Or we can say this is 5 times 4 times 3 times 2 times 1. 5 times 4 times 3 times 2 times 1, which is 100. 120. They say now repetition of digits is allowed in the code. If they allow repetition, meaning that I can choose a digit, I can use any digit. So now this is 10.2.2. Digits allowed. This is 5, exponent of 5, which is NR, which is 3,125 digits, meaning that I can choose out of 5, out of 5, out of 5, out of 5, out of 5. So for 5, I can choose out of 5 because now I can repeat the digits. And that's okay. Then 10.3, let's focus on 10.3. Then now 10.3 says a group of 3 South Africans, 2 Australians, and 2 Englishmen are staying at the same hotel while on holiday. Each person has his or her own room, and the rooms are next to each other in the straight corridor. The rooms are allocated at random. Determine the probability that the 2 Australians will have adjacent rooms, meaning that their rooms are close to each other, and 2 Englishmen will also have adjacent rooms, meaning that they are also close to each other. Then now we're going to arrange this. For their rooms to be close to each other, these ones, meaning that they had their own arrangement, because they're 2, they will have their own arrangements. Yes, they are 2. Also, these 2 will have their own arrangement. So already we had 2 arrangements already. So now, sorry, these arrangements they are made. This arrangement they are made. So we have 2 arrangements made, another 2 arrangements made. But now these 2 arrangements that are made, there are 2 arrangements made already. They have to be arranged again with a. So how many arrangements are here in total? There are these as 2 arrangements, and now we have another 3 of South Africans. That makes them 5 arrangements. So arranging this only will give us this. But now they said the probability So now let's check the probability of arrangement of the rooms. How many are here? We have 7. So we can think 7. Total, so there's a 7 factorial of arranging these people in any way. So now, but this is the number of arrangements where there's 2 Australians are next to each other and 2 English. This will be the arrangement. This is the arrangements of the Australians. This is the arrangements of the English. All together, they form 5 arrangements because this been arranged together. It's not done. It's not done. They are just been arranged. They just been arranged, but they can be arranged again versus the truth. So this arrangement is taken as one arrangement. We take this as another arrangement. As they are here, they are 1. Here, they are 1. So now there are 3 South Africans to be arranged. So it's 3 from South Africans, 1 here, 1 here, which together makes them 5. But here it's when they're just arranged in any way. So now let's check how many of the 2 factorial times 2 factorial times 5 factorial. So being arranged in this way, they can be arranged in 480 ways. Then all together, without any order, they can be arranged in 5 or 4. So these are the 5,040 ways of arranging of these people, but 480 ways is to arrange them being close to each other. So what now the probability now what we're going to deal with is 480 divided by 5054. Why? This is the total number of arrangements, regardless of whether who is where. But here is the arrangement where these are close to each other. What will be our arrangement? To be the probability of having them close to each other. That is 2 over 21.